Hey guys, how's it going? My name is Isaac Spiegel, and I'm here to show off this point cloud keyer that I've been working on. The point cloud keyer is unique to Nuke for a couple reasons, but one of them being that it is a two-dimensional keyer. Some other keyers in Nuke, like the keyer, are a one-dimensional keyer. They pull a key on a single color channel. Some keyers in Nuke are 3D keyers, like the Primat, which maps the three channels, red, green, and blue, in 3D space, and then draws a shape around the areas that they're trying to key to pull a mat, or they're algorithmic keyers like the key light, which use some sort of color difference um, processing to pull out a mat. The keyer that I've been working on, the point cloud keyer, is a two-dimensional keyer, meaning that it keys on two channels. Specifically, the ones we're interested in are, well, first of all, color spaces that can separate value information from color information, something like HSV or YCBCR. In this case, the default on this node is the chroma red blue, which uses the YCBCR color space. Basically, it plots the blue chrominance on one axis and the red chrominance on the other axis, making it a two-dimensional keyer. So how does it work? Well, you need to take your footage that you're looking to key and plug it into the source input of the point cloud keyer. You have an optional input here for any background footage that you want to view as well. And we're going to take a look at the keyer here. And what we see is a 2D representation, a 2D point cloud representation of the colors of our original plate. Looking at this 2D representation, we can scale it to be a little bit larger and maybe move it around a little bit to get it into a nice position. And we want to be able to get a clear view of the colors in this point cloud, because the next thing we're going to do is place a rotoshape down and connect the shape input to our rotoshape. It's important that the rotoshape and the footage are trying to be the same resolution, so you can hook in the background of the rotoshape as well, and maybe just make sure we replace the alpha. Great. So looking at this rotoshape, we can go to the root here and draw a shape around the pixels or the colors that we want to remove. Maybe we can give that a little bit of fall off as well. And we can see now that what we've done when we go to our final result is that that has given us a beautiful alpha channel from our footage. That's pretty cool. So at the heart, that's basically how the tool works. Plug the source into the source footage, you plug the shape into a rotoshape, you look at the point cloud output of the keyer, and you draw the shape over the color pixels that you want to use. Now we can make this experience a little bit easier with a few additions to this tool. First of all, you're able to, as you're looking at the point cloud, you're able to swap the axes of the 2D representation here. Remember how I said earlier we plotted the blue difference on the x-axis here and the red difference on the y-axis. What this means is that pixels that are more red will have a higher red difference and will appear closer to the positive y. Pixels that are very blue in color have a high blue difference and will appear further in the positive x. Green kind of falls in this area that doesn't have a lot of red difference and doesn't have a lot of blue difference, so it will fall closer to the origin. Now if we wanted to reverse the axes, we can click on the swap axis, and all that simply does is plot the blue difference pixels on the vertical axis and the red difference on the horizontal axis. This might give you a slightly better or easier time masking out the colors that you need. Next, we can look at the color space. Typically, the chroma red blue, the YCBCR color space, is typically going to work for most cases. However, there's some cases where you might want to use the chroma XY, which is the YXY color space. It's kind of like YCBCR, but slightly different math. You can also use the chroma and hue, which is a representation from the HSV color space, which will plot the hue on one axis and the saturation on the other axis. Sometimes this will get a good result for your footage. You can look at the red-blue average, which if I turn the scale down a little bit, you can see the red-blue average a little bit. This is basically adding the red and blue channels together and dividing those by 2 and plotting that versus the green. Again, sometimes that you might find that helpful, or you can set this to custom. Plug in your custom arrow to whatever sort of 2-channel color space or color information that you want, and you could use that as your X and Y axes. The next thing that we'll be able to do, let me just adjust this shape a little bit here. Maybe we can scale it back up. Yeah, something like that, and maybe translate it up a little bit like I had it before. Nice. The next thing that I've added that could make this a little bit easier, if you go over your composite view, here you get to see what the output of this node would be. Now, you'd be able to plug in a background if you wanted to see this over a specific background. But what I like to use this for is for being able to edit the point cloud while still being able to see your alpha channel. So with this overlay point cloud option here, you're now able to see the point cloud that you're editing on, and you're able to adjust your alpha, your rotomesk, to find an alpha that works best for you. Now this is really great and all. Sometimes you might want to see these points a little bit thicker as well, make them a little bit more visible. You can use the dense point cloud option, which will display the same point cloud but kind of just erode out a bit on the on each individual dot point on the point cloud. Again, just to make it a little bit easier to see what you're doing as you're using the tool. This can also work with in the final result mode as well, although it's, admittedly a little bit less useful. You can still see your alpha, but I think it's best to see over the composite how your image is being affected by the changes in your mask. Finally, at final result, with our alpha, we have the ability to invert the alpha as well. Cool, that's the basics of how the point cloud keyer works. Let's dig a little bit under the hood just to see kind of what's going on. So we can start up here with our input footage, and we can see we have a couple different color spaces like I was talking about. So basically this takes a footage, converts it to that specific color space. The only one that's not really a color space is this red-blue average, which takes the average of the red and blue and plots it against the green. Next we have these 2 shuffle nodes here, and these are for the axis switching. It's also important to get whatever color channels we want from here. They need to be in the red, or sorry, the red and green channels after this, because those are going to get plugged into an ST map. ST maps are looking for a UV channel, which means information in the red channel and information in the green channel. So we see, for example, the YCBCR color space, it has red as Y, green as CB, and blue as CR. So we're going to need to shuffle the blue into the red channel and the green channel into the green channel still, or sorry, the blue channel into the green channel. And we can see that here, red to green, green to blue, and the opposite for the horizontal. Finally, we have a gray node, which does all of our transformations for us. We have the black point and the white point, which control the scale, and the offset, which controls the translation. Red for the X and green for the Y. Moving on, we have this ST map. So after reading in our source footage, converting it to the right color space, separating the color information from the value information, shuffling that into the red and green channels, we can plug that, red and green. we could plug that into an ST map, which takes in as the source the input roto shape that is provided. And then looking at the ST map at the alpha, it creates an inverted alpha of what we're looking for. So we got to make sure we invert that. Finally, we can take this new alpha, copy it into our original footage, and we can output that information. Now for the point cloud preview, we use a slightly modified STMap, I'm going to call it. So again, starting with the grade, we use this Blink script kernel that is a reverse STMap, and this was, as you can see, made by Mads and modified by Erwin Leroy, which are two very smart people. And this inverse STMap is basically doing exactly what the normal STMap would be doing, but just flipping it. There's a little bit more information on that on the blog post that accompanies this video. But anyways, this inverse ST kernel outputs our point cloud image. And again, if we want to have the thicker point cloud, we take a blur and a little expression here to play with the alpha a little bit and a premult, and we can merge that under for the thicker point cloud option. And just over here, we have the BG information being merged in as well. So that is the point cloud keyer. Thanks a bunch for watching, and I hope you can find some use out of this tool.